In this chapter we understand the architecture and operations of a 2D graphic system, and also we understand the 2D coordinate system and equations of graphs, and we are able to identify the various coordinate space in rendering pipeline. And we understand the Java 2D program structure and the graphic 2D object, and we graph equations with Java programs, and we see some basic 2D geometric primitives, and we construct custom shapes using the general path geometry and construct geometric shapes through the constructive using the general path and using the constructive area geometry. The first, as a definition, the coordinate system is a method to associate geometric points with algebraic quantities of ordered tuples of numbers. Parametric equations, which is a set of equations that express coordinate variable as function of parameters. Word space is a common reference coordinate space for graphic models. Object space is a local coordinate space associated with a given or an individual object. And at last, the device space is a coordinate space used by a specific output device. For the first example, we want to find the actual angle spanned by the arc, which is arc to the arc equal new arc to the float 20, 30, 100, and we have 80, 45, and 125. 2030 is the upper corner of the rectangle containing the ellipse, and 100 is the width of the ellipse, and 80 is the length of the ellipse. 45 to 125 is the angle of the arc. So we can calculate the actual angle is by adding from 45 we will add 125, which means the angle will start at 45 degree and then it will end at 170, which means 45 plus 125, which is equal to 170. The second question, which is determine the interior of the following shape using the even odd rule and the non-zero rule. First, for the even odd rule, we will try to take from each region a straight line from the region to the outside and try to count the number of line crossing. If the number of line crossing is odd, then the region will be an interior region. If the number of line crossing is even, then the region will be an exterior region. So we will see here in the example. For example, if we take any region and try to take, we will count the number. For example, this region, the number of crossing will be 1. If we try to take another region, which is the smallest one inside, and we try to count the number of crossing, which will be equal to 3, then the region will be interior, and same for the other region. We take also a line from the region to the outside and then count the number of crossings. As for the non-zero rule, we will count the number that for the direction of the straight line. So here the direction is very important, and without it we cannot calculate if the region is interior or exterior. The principle here also, we will take a straight line from the region to the outside and then try to calculate the number of the direction of the crossing lines. For example, we take if the crossing line is downward equal to +1, and if it is upward equal to -1. If we take from the smallest region and at the middle a straight line from the interior of the region to the outside, for example, the downward line which would be +1, the other downward line also +1, then +2, and the upward line will be -1, +2, -1, the result will be +1, which means the region will be an interior region. Here in this example, we want to calculate the output of the following code. First, we will move to a point 100, 100 from the center. Then we will move through a curve 2 from the point 120, from the 100, 100, passing by in the direction of 125, 125, and the other point in the other direction 175, 75, and the curve will end at 200, 100. And then from the point 200, 100, then we will make a line to the point 150, 200, then a quad to curve in the direction of 75 to 100, 100, and then we will close the path. Then we will move to another point 50, 50, then we will make a line to the point 250, 50, from 50, 50 to 50, 50, and then from 250, 50 a line to 250, 250, and from 250, 250 a line to 50 to 50 to 50, and then we will try to close the path and we draw the path. Here is the output as we can see for the previous course. Here is the curve 2, and here is the quad 2, and here is the line 2, which is a square. Write a Java code to construct an ellipse of width 80 and height 100 centered at 100, 300 in a green color. To write this Java code, we first want to construct an ellipse centered at 100, 300. Then we should calculate the upper corner of the ellipse, and then we should set the color of the graphics to green color. Here is the code of constructing the ellipse. The ellipse is of width 800 and height 100, and the upper corner of the ellipse is 60 to 150. Since as we can see here, the ellipse should be centered as we see before at 100, 300. Then we will subtract half of the width and half of the length, which will take us to 60 to 150, the coordinate of the upper corner of the rectangle, and the width of the rectangle containing the ellipse is 80, and the length is 100. And then we change the color by set color of the graphic color dot green, and then we draw the ellipse. Here a program is written to run both an applet and application. The hello or the exercise 1 class extends gapplet A main method is also included that creates a G-frame window and adds an instance of example ex1 to the window. The applet contains an instance of ex1. The paint, okay, here is, as we can see, here is the code. The paint component method of the subclass is invoked first to handle the necessary cleanup operation. The graphic object G is cast into a graphic 2D object G2 to use Java 2D feature. The parameter G is declared as graphics, but it is actually a graphics 2D object in all versions of Java that include Java 2D. So the drawing color is here as it is in the graphic. Note that all we should know and implement in this is the paint component, and the remaining code will be used to run the application. Here is a code to draw a parametric equation, which is 2t math.cosine t and 2t 20t, sorry, math 2t cosine t and 2t sine t. To draw the parametric equation, we first declare int x1 equal 0 and y1 equals 0. If substitute instead of t 0 0, then the first point will be 0 0, and we declare x2 y2, which is the another other point, and for loop on the needed point, which is n point, which is 1000. Then we try to calculate x2 y2 starting from 0 or 1, it is the same, and then we calculate x2 y2, and then we draw a line from x1 y1 to x2 y2, and then we substitute x1 will be x2 will be x1 and y2 will be x1, and then try to calculate another x2 until we draw all the points and the line between them. Here is the output of the parametric equation 20 t cosine t and 20 y x equal 20 t cosine t and y equal 20 t sine t. Here we should write a Java program to plot the parametric equation which is x equal t square and y equal t cube. Here is the paint component of the previous code. First, we try to translate a graphic to 100, 300, and then we will try to draw the axis to see the graph clearly. Then we try to take the first point for t equals 0, which means x1 will be equal 0 and and y1 will be equal 0, and we, as before, we declare x2 y2, and we make a for loop on all the points, and then we calculate x2, which is t times t, and y2 t times t times t, and casting it by instance x2 and y2 cannot be can also be an integer. It cannot be used as a decimal point. And then we try to draw a line from x1 y1 to x2 y2, and then we try to put x2 in x1 and y2 in y1, and trying then to calculate a new x2 y2 until the number of points finished. Here is the output of x equal t squared and y equal t cubed. In this exercise, we should write a Java program that will display the following shape using constructor area geometry. Here, as we can see, we can draw this shape by drawing two ellipses or circles, and then trying to subtract these two circles. So here is the answer by using the paint component method. And first, to create the first ellipse, which is ellipse to DE equal new ellipse to D dot double for the upper corner 0 0 and the width and the length of the ellipse is 300 300, and then we try to declare an area moon which is a new area, and here is another ellipse E1 which is a new ellipse. The upper corner is 100 minus 50 and the width and the length of the ellipse is 400 400, and we try to calculate how to declare create an object of area E2, and then we make the first area dot subtract the second, which means moon dot subtract A, and then we try to fill the moon. Write also the same the Java code to display the following shape using constructive area geometry. Now we will using general path. First we draw it using constructive area geometry. Now we want to draw it using general path. Here we can use the quad 2 or curve 2 to draw this region or this shape. So the solution is here. First we have we create the general path by using the even odd rule. Then we move to a certain point. Here is the move to point 150 and we try to draw curve 2, which is from 150 a curve in a direction of minus 50 50, and then in direction minus 50 250 to reach the point 150 300, and then a quad 2 from 150 300 in the direction of 50 150 to reach the point 150 Then we close the path and we try to fill the path to have the previous shape shown in the previous slide.